Bismillahirrahmanirrahim. I welcome you all in F6 Online Sport and Assignments tutorial for round 2 week 4. I am Zubiar Zak from APH Company. The grade is 7 and subject is science. Recipe is chapter number 4, water and sound. Task 1, that is about sound. So sound is a form of energy that can travel from one place to another. Our ears can detect this energy, so that is the way we can find out what is going on around us. Sounds come from many different sources. Some are pleasant, other can be dangerous to our hearing. So in a guitar, it is the strings which vibrate. When a dog barks, its vocal cords vibrate. The hammer strikes the bell to make it vibrate and ring. Lightning explosively heats air, making it vibrate. Test, test yourself. Question number 1 is, how do humans and other animals detect sound energy? So the answer is through ears. How are sounds made? So sounds can be made by vibrations. Name one example of a source of a sound that has vibrating strings. So I have discussed. And B part is that directly vibrates the ear. So I have discussed it in my previous slide. How sound travels. If we are listening to a drummer in a band, we do not have to put our ear on the drum skin to hear the beat. Sound can travel through the air. The sound is carried to our ear by vibrating molecules in the air. So the process is, in first step, when the drummer hits the drum skin vibrates rapidly up and down. Then the second step is, the air molecules are squashed together. Third is, the air molecules spread out again. And in fourth step, the sound spreads out in all directions. Describe how sound is heard when a drum is hit. So I have discussed it. What evidence is there that sound travels through gases, liquids, solids? The first evidence of gases is we can hear sounds all around us. And in liquids, dolphins communicate by sending out high-pitched squeaks and clicks which travel through the water. And in solids, we can hear someone knocking on the door and the sound of a beating drum. Explain why sound cannot travel in a vacuum. In vacuum, the sound cannot travel because there are no particles in it. Next is sound as a wave. When the cone of a loudspeaker vibrates, it moves in and out very quickly, stretching and squashing the air in front of it. The stretches and squashes spread through the air, rather like the ripples in a pond when you throw a stone into the water. These are the sound waves. When they reach our ears, they make our eardrums vibrate and we hear a sound. Model of a sound wave. So here is a slinky spring. When a loudspeaker squashes the air in front of it, the air molecules are forced closer together. This is compression. So in first step, you are watching that spring is coming closer. So here is compression. And in second step, you are watching rarefaction. So here the spring is stretching. When the loudspeaker stretches the air, the molecules are spread out. This is called a rarefaction. So wavelength is the distance between two compressions or two rarefactions. The wave on a spring and sound waves are called longitudinal waves because their vibrations move backwards and forwards, not up and down like waves on the sea. A sound wave is an example of an oscillation. So an oscillation is a regular backward and forward or upward and downward movement. Test yourself. Question number 1 is, what are sound waves? Sound waves are stretches and squashes of the air spread out from the source of the sound. In sound waves, what is the distance between compressions called? So it is wavelength. What is a longitudinal wave? The vibrations move backwards and forwards. So it is a longitudinal wave. Question number 4 is, how are sound waves different from the waves in a sea or the ripples on the water? The waves on a sea or the ripples on water move upward and down, not backwards and forwards like longitudinal waves. These are home tasks for the day 1. You have to read and memorize the concepts of textbook pages 58, 59 and 60, and you have to do these tests yourselves from textbook pages 58, 59 and 60. Task 2, that is about speed of sound. Sound waves take time to travel. In fact, sound waves take about 3 seconds to travel 1 kilometer. Light travels the same distance in an instant. This is why you see lightning before you hear it. In air, the speed of sound is about 330 meters per second, although this can vary depending on the temperature. Sound travels at different speeds in different materials. In general, it travels faster in liquids than in gases, and it travels fastest of all in solids. Reflection of a sound, echoes. Walls and other hard surfaces reflect sound waves. When you hear an echo, you are hearing a reflected sound a short time after the original sound. So it is an echo. Test yourself. Question number 1 is, what is the approximate speed of sound? So it is 330 meters per second. Does sound travel at the same speed through all the materials? No. In general, sound travels faster in liquids than in gases. It travels fastest of all in solids. Question number 3 is, in a thunderstorm, the thunder is made at the same time as the lightning. Explain why a person 1600 meters away hears thunder about 5 seconds after seeing the lightning. So you have to divide distance by time. So you can find the speed of a sound by dividing distance by time. You will write 1600 divided by 5, then you will get your answer. Question number 4 is, what is an echo? So I have discussed it. What is echo time? I have discussed in this slide. Calculate the speed of a sound in the example of echoes using the formula. You will take the example of the girl in the picture above is sitting 80 meters from a wall. Each time she hits the metal bucket, she hears an echo of 0.5 seconds. 0.5 seconds later. This is the echo time, and it is the time taken for the sound to travel the 160 meters to the wall and back again. So here you will write speed is equal to distance by time, and you will write distance as 160 and time 0.5 second. So you will get your answer. Next is the pitch of a sound. So the pitch of a sound means how high or low the sound is. It depends on how rapidly the sound producer vibrates. Next is frequency. The frequency of a sound is the number of vibrations set up in 1 second. It is measured in hertz. I will discuss about test yourself. What is meant by pitch? I have discussed. The frequency of a sound I have discussed. And question number 2 is, the frequency of a drum note is 20 hertz. What does this tell you about the drum skin movement? It means that the skin of the drum vibrates 20 times in a second. Question number 3 is, a drum is hit hard and then softly. How does the volume change? How does the amplitude change? So when the drum is hit hard, a loud sound is produced, that is high volume. When it is hit softly, a quiet sound is produced, that is low volume. And B part is, when the drum is hit hard, the skin of the drum vibrates with a high amplitude. When it is hit softly, the amplitude of the vibrations are smaller. Question number 4 is, what is the wavelength of a sound with a frequency of 330 Hz? Take the speed of a sound in air to be 330 meter per second. So you will write 330 meter per second as the speed of sound, and you will take 330 Hz as frequency, and you will divide 330 by 330 and you will find the wavelength, that will be 1 meter. This is the textbook page number 64, and you have to solve exercise question number 1 and 2 on your textbooks with your lead pencils. These are home tasks for the day 2. Thank you and have a nice day.